Hello there, class. This is the last section of Chapter 3. About time, right? We've had 8 sections. This one is called Differentials. And let me talk to you about differentials and what it means. If you remember, the derivative formula is f prime of x equals the limit as delta x goes to 0 of f of x plus delta x and then minus f of x all over delta x. So I think you remember this. And our goal was to get the limit at x as close to 0 as possible. So in theory, we were dividing out and getting just the top. So this delta x really never equals 0, like a misnomer, okay? However, it's very, very close to 0, all right? So it's the difference between theoretical and actual. In theory, it never really gets to 0 at all. But actually, we make it like it almost is 0. So if that's the case, then I'm going to say, using this, I'm going to say f prime of x times dx is equal to, if I call this guy down here dx, the difference in x, or delta x, okay? That is equal to the top. I don't know why I changed. There we go. We're going back to blue. All right, we're back to blue. Okay? And this actually is delta y. And that's equal to fx of delta f plus delta x minus f of x. This is a formula that if I were you, I'd write down. Anna Gordon, write it down in that notebook, that new notebook you're getting. And that's a big thing here. All right? Sometimes, by the way, this is called dy. This whole thing is called dy. So that would bring me to the following formula. dy is equal to f prime of x times dx. So both of these are formulas that you're going to use. I think we use this one more, but it's 50-50. So you might say, well, you've done a lot of mumbo-jumbo here. What's going to go on? So I got a problem for you. Use differentials to approximate the change in area of a square if the length increases from 6 to 6.23. Now, of course, excuse me, of course, I can calculate the 36 here and calculate whatever 6.23 is, square it, and, I'm being asked a question. Hold on. Yes? Oh, okay. Oh, I have a camera here. So, so we have, once again, we can take the side length of the square, 6 centimeters. We could square it, and then you could get the volume of the area of the square, which is 36. And then you can take 6.23, square it, get the area, and find out what the difference is. Well, we don't have to do that. That's an easy example, meaning that there's not a lot of calculations involved. When the calculations get crazy, I'd like to know how the area is changing pretty quickly instead of going through twice and putting it into some formula. So here we go. So dy is equal to f prime of x times dx. And the function we're talking about here, our f of x, is x squared. So now what we're going to do is we have our derivative. We say dy is equal to the derivative of this thing is 2x times dx. So now we plug stuff in, and we get 2 times 6. And the difference in x, the difference from 6 to 6.23, is 0.23. And now we'll get how the difference in y is. Difference in y is 2.76 square centimeters. And that difference in y is really the difference in the area. So that's how the area is changing given that 6.23. That's it. I mean, I could prove to you and show you that the other one comes out to be 38.76, and then you can find out what the difference is, but much easier here, all right? Let's go to the next one. Next problem. More classic problem here. Use differentials to approximate that square root to the nearest thousandth. Just want to choose, and what we're going to do is we're going to guess at this, and we're going to guess at something we know. So we always want to take a guess. Take a guess at some cubic you know, something you know. So I am going to choose y equals the cube root of 27. Cube root of 27 is 3. So I'm choosing something that I know what I'm doing with. All right? Which means my delta x, how far off am I from this original problem? I am 0.45 off now. All right, we're ready to go. We are ready for this, folks. Let's do what we did before. Green looks kind of nice here. All right, so this is going to be the cube root of x. So this is the cube root of x. That's y. So now it's going to be dy is equal to, well, we got to now take the derivative of x to the 1/3, which is 1/3 x to the negative 2/3. So I'll just put it on the bottom. All right, one swoop times dx. So this is going to equal dy, or going to imply dy equals 1 over 3 times 27 to the 2/3 power times 0.45. 0.45. Let's do that so there's no confusion. That answer comes out to be negative 1/60th. All right? Because over here, 2/3 of 27, I guess 2/3 of 27, I don't know what 27 to 2/3 is. I'm guessing it's 9, and 9 times 3 is 27. That's my guess. Yeah, that works. So that'll work. It's no problem. Or you can give me the decimal equivalent, whatever it is. All right, but we've approximated with what the difference is of 26.55. So 3 minus, I guess this was this is equal to negative 0.0617, which means that if we approximate it, we knew the cube root of 27 was 3, and now it's 3 minus this, and that's going to be 29833. So 2.9833 is the approximation I get of the cube root of 26.55. That's it. All right. Quick note. I have my quick notes here, and I'm going to add one more. We saw this on the last slide. We saw this on the last slide. Now we're going to talk about percent of change, and we're going to do a problem regarding percent of change. So, it's my last problem. Look at the area of a circle. What's the percent increase or decrease? That means decrease or increase using differentials of the area of a circle with radius changing from 20 to 20.2. 20.2. So my function is the area function. I like this green. I'm digging it. It's equal to A equals pi r squared. I just want to tell you, it's been really hard teaching right now because we had Free Falling on before, and now I have Sweet Child of Mine, and I can't get Step Brothers out of my head. I'm just telling you this. All right, so we can take derivative. Derivative is dA equals 2 pi r, and then dr. Well, we have the 2 pi, we have the r, which is 20, and the difference is 0.2. So, I don't know what that turns out to be. I really don't. I'm going to guess 8. Difference in area is 8.04 pi. And let me talk to you about percent increase or decrease. From the last slide, percent increase or decrease is dy over y of x. So let's see. The original dy, which I found, is 8 pi. And the area was 400 pi, and that was this is originally, oh man, 1 second. Man. So dA over A. Okay? dA, I'm wrong, by the way. I don't like to be wrong, but I'm wrong. dA, if you do all that calculation, it's just 8 pi, not 8.04 pi. So it's 8 pi. So dA is 8 pi. The original area would be 400 pi, and we get 2%, which is a 0.04 increase, and that's what it was. All right, so we get a 2% increase in our area. So we like to talk about percent increase and decrease. All right, homework or practice problems, page 240. We're going to try, these aren't in order. Oh, they might be. 10, 14, 18, 27, 30, and 16. I don't know why 16 is at the end, but it is. All right, once again, differentials, just a recap. We have percent of change, dy over yx. That means the original function. And we have these other two formulas. We did three problems. We did percent in increase in area. We've done this to the 1,000. We've estimated some square roots using differentials. And the first problem we did, which was to find how an area decreases or increases given an increase in size. Just using differentials other than going through the whole process. All right? Any questions? We'll talk tomorrow. Thanks.